Now we're looking at how the predict function works for a regression tree, and here I'm using the package party. So suppose I run a tree. This time I'm purposely doing something different. Suppose I'm trying to predict a categorical variable um, like species. Okay, so that didn't work because I have to do this first, and then it'll work. And I can make a picture of my tree. So there it is, right? So I'm trying to predict species using petal length and petal width, right? I can't make this quite wide enough to fit all three species names in the bottom, but the point is it's dividing the flowers up and then within each final node telling me how many of the flowers in that node were from each species. This is like the Federalist Papers problem. There's my tree. So I could use my finger to try to figure out, what the prediction is for any particular data point, but this is parallel to what we did in the regression case. If I have a data set that looks like a row from the original data set, so for example, maybe the first flower is the one I'm trying to make predictions for, I can say predict, the first argument is the output for my tree, second argument new equals, and I give it this data set that again is a row from something that looks like the original data set. What it'll do is tell me what its prediction is for the first flower, and the prediction is setosa, because in the node that first flower ended up in, the most common species was setosa. Note that R will always, for a categorical variable, list the possible levels of that categorical on the bottom, so you don't need to be worried about this. It's just telling you that the prediction is setosa, and the choices were setosa, versicolor, and virginica. One other thing to note here, suppose you wanted to know not only what the prediction was, but how within that final bar plot, what proportion of the flowers were this particular species, right? Now what it's doing is it's telling you, okay, for the first flower in the data set, it ended up in a node where 100% of the time the flowers were setosa. They were never versicolor or virginica. But if I tried this for some other row, I'm gonna make one up here. I'll still call it first flower just for a second. Let's do this. Okay, it's telling me that the 80th flower ends up in a node where 0% of the time the flowers were setosa, 98% of the time they're versicolor, and 2% of the time they're virginica. So adding type equals prob gives you not only the categorical prediction, but also the percentages. One more thing to note, just that this predict function will work here only if you specify the model with outcome variable tilde some of the predictor variables comma data equals and then specify the data set. It does not work if you write data $sepal width, data $sepal length, etc., etc. It won't be able to find the variable names. The last one here is the spline. I like to use smoothed out spline because it looks a little bit better. The input of smoothed out splines like this. You specify the X variable and the Y variable. Okay, and so I can do that here. Now there's a difference in the predict function for splines as opposed to trees and regression, which is you don't say new equals, you say X equals. And here, because we're only using the spline where there's only one predictor variable, you can just put in a number like 3. Okay, so I don't, the second argument of the predict function for a spline is called X instead of new, and it doesn't have to be an entire row from a data set. It could just be a number or a vector of numbers if you want multiple predictions. Okay, so this is telling me that if I draw a spline to predict petal length using petal width, well, that spline says that when petal width is equal to 3, petal length is predicted to be 5.9. That's what this says. Okay. Note that again, this is different because you don't have to worry about variable names. You literally say X equals and then give it a vector of numbers.